Hi, welcome to my video on find from the equation of ellipse with center h comma k, find the vertices, foci, the length of the major and minor axes, and the eccentricity. A couple of videos ago I did the same thing, but the center was 0, 0. This time the center is going to be h comma k. So let's recall the standard form of ellipse. X minus h all squared over a squared plus y minus k all squared over b squared equals 1. And a squared is greater than b squared. So that means that this number here is larger than this. As a result, we have the center is the opposite of whatever integers are in here, or it could be any numbers, but let's assume they're integers like 3 and 4, but don't have to be. It could be a half, it could be irrational number roots, but normally they're integers. So the center is hk, the opposite of whatever these values are. And the major axis, because a squared is larger than b squared, the major axis is horizontal, and the minor axis is vertical. And the length of the horizontal axis is you take the square root of this number, which is going to be a, so you double it. It's twice the length. Because this number, whatever a is, if the a, whatever this number is twice that, because it goes to the right and goes to the left to get the length. So that means the vertical must be 2b. So you get the square root of this number, and you double it, and you get the length of the minor. And the major is always longer than the minor. That's what makes it oval, the ellipse. And the vertices, well, we have because it's horizontal, that means we have an h, and the a is added to the x value. So it's h plus or minus a k. And the co-vertices are, if the major axis is the horizontal, the co-vertices lies on the minor. So the minor is the value of y. So we add plus or minus b. So the stretch is a, so it's added to the x plus or minus. And the vertical is you add it to the y to go up and down. So it's the k, y value plus or minus the b, which is the stretch. And we have the foci, and the foci, these are the marked vertices here. You know what I'm talking about. And this is, just mark the length here, just to make sure. This is the co-vertices. Again, vertices lie on the major, co-vertices lie on the minor. And the foci are on the vertices. So it's the foci distance is c, so it's h plus or minus c, comma, k. And we have the eccentricity. Eccentricity is E is equal to c over a, the length, whatever the distance from the center. So the distance from the center, it's the c over the a. When we do the next part of this video, the vertical will be the major, so it would be the c over the b. And PF1, the distance from the point to foci 1, plus the distance from the point to foci 2, is always 2a. So this is the length of the major. So the distance from a point to each foci is the length of the major axis, which is 2a. And the value of c, the distance that the foci is from the center, is a squared minus b squared. And again, it's the larger number here, subtract the smaller number, a squared minus b squared. Now let's do an example based on the ellipse. We have an equation here. Again, it's a plus with the square, so it's an ellipse. X minus 1 all squared over 100 plus y plus 2 all squared over 64 equals 1. So the major axis is the horizontal or vertical. Well, because the 100 is larger than 64, the major axis is horizontal. The length of the major axis is, so we have 100 here, so that means that a squared is 100. So a is plus or minus the square root of 100, which is 10. And that's the a, and this is the b, so b squared is 64. So b is the square root of 64, which is plus or minus 8. So the major axis is, again, this is the major, which is involved the a, so the major axis is twice a, which is twice 10. So the length of the major is 20. So from the center, you're going 10 to the right and 10 to the left, so it makes it 20. The minor is 2b, so it's 2 times 8. B is 8, so the minor is 16. So the minor axis, which is the vertical, is up 8, down 8 from the y value in the center. And the center is the opposite of -1, which is 1, the opposite of +2, which is -2. And the PF1 plus the PF2 is the length of the major. The major axis is the A, horizontal, so it's 2 times A. And 2 times A is 2 times 10, so the PF1 plus PF2 is 20. Now the vertices on this ellipse, the vertices are the horizontal, so it's the center of 1, and it's horizontal, so we add the 10, plus or minus 10, comma, -2. That's the vertices. So we get 1 plus 10 is 11 minus 2, and 1 minus 10 is -9 minus 2. And the co-vertices, the vertices lie on the major, which is the x, the co-vertices lie on the y. So we have a 1, so we're adding to the y value of -2, so -2, the length of the minor is 8 double 16, so it's a plus or minus 8. So the co-vertices are 1, and -2 plus 8 is 6, and 1. -2 minus 8 is -10, so that's the co-vertices. Again, vertices lie on the major, which is the x, horizontal, so you're adding the stretch. If you think of this as 100, you think the square root is 10, so really A is the horizontal stretch left and right, and 64, square root is 8, so the vertical stretch is up 8, down 8. So think of the square root of this as a stretch. So this is a vertical stretch, horizontal stretch. The foci is on the major, which is the x, so it's 1. Now we have to calculate what the c distance is. So, and we don't have it, so c squared is equal to a squared minus b squared. A squared is 100. B squared is 64. C squared is 36. And c is plus or minus the square root of 36, which is 6. So c is plus or minus 6. So this is plus or minus 6. And -2. So the vertices is 1 plus or minus 10. The foci is 1 plus or minus 6. Vertices are further out from the center. Foci are in between the center and the vertices. So that gives us 1 plus 6 is 7 minus 2. 1 minus 6 is -5 minus 2. And the eccentricity is the c over the a. A is on the major axis, so the c is 6. C is 6. It's got to be positive. And the a is right here to be 10. So the eccentricity is 6 over 10, could be 3 over 5, or you could have a decimal as 0.6, either or. Now let's graph this ellipse. So we have a center of 1, -2, which is here. the vertices lie on the major, so we have 11, negative 2, 11, negative 2, right here. Negative 9, negative 2, negative 9, negative 2 right here. And you can see the center is the midpoint of these two. If you add these coordinates up, if you took the coordinates of the vertices and added them up and divided, got the midpoint, you would get 1, negative 2. 11, add on negative 9 is 2, divided by 2 is 1. Negative 2, add on negative 2 is negative 4, divided by 2 is negative 2. So, and the co-vertices are x is 1, y is 6, and x is 1, y is negative 10. 1, negative 10. So the ellipse is again, these are the vertices, and these are the, I'm going to call CO vertices. And the foci are on the major, so the foci are at 7, x 7, negative 2, 7, negative 2, and we can, and is that negative 5, x is negative 5, negative 2, so we can call that foci 1 and foci 2. Notice the foci are on the major axis. This one is a horizontal. Okay, let's look at another one, and and this time we have the same equation, only b squared is greater than a squared. So it's the same equation. The center is h comma k. The major axis, because b squared is greater than a squared, this excuse me, this number here is greater than this one. That means the major axis is going to be vertical. The minor axis is going to be horizontal. And the major is, that's b squared, so the major is the vertical, so the length is, you take the square root of this number and double it. And the minor is the horizontal, which is with the x, so it's a 2a. And the vertices are, and the vertices is vertical, so it's added to the y value. And the co-vertices is horizontal, so the a is added to the x value. Because the major is vertical, then y is the vertical, so the b is added to the y value to make it go up and down. The co-vertices are on the minor, which is horizontal, so the minor is the horizontal, so the a is added to the h, which is the x. And we have the foci. Foci are on the major, so the major is here, says h. We have a k, and the foci are plus minus c, distance from the origin. And e is, this time e is the c over the b. When it's vertical, the longer axis is the y, so it's the c over the b. This number, when it's horizontal, it's the c over the a, because the horizontal is the major axis. And pf1 plus pf2, in the vertical, it's the b, so the length of the major axis is 2b, so pf1 plus pf2 is 2b. The length of the major axis is what the distance from the point to each foci is, twice what b is. And we have c squared. This time, because b is larger, it's b squared minus a squared. In the horizontal ellipse, it's a squared minus b squared. There's always this larger number. Whatever number is here, it's the larger one, subtract the smaller one, the way I remember it. So let's do an example. Number 2. we have an ellipse. Again, ellipse has a plus, and with two squares equal to 1. And we have the major axis is horizontal and vertical. So 25 is larger than 9, so it's vertical. So the major axis is vertical. That means the minor axis is horizontal. So the major axis, so let's go on. This is a squared equals 9. So a is plus or minus 3. B squared is 25. So b is plus or minus 5. So the major axis is the vertical. So it's twice b, which is twice 5. So the major axis is 10 long because it's 5 up, 5 down, 10. The minor axis is the a, is 9. So a is 3, and we get a 6. Notice in terms of length, I don't put a negative in here. I just put a positive to get distance between them. The center is opposite of plus 3, which is minus 3. Opposite of a negative 2 is 2, so that's the center. PF1 plus PF2 is the major. The major is the 2b, and 2b becomes 2 times 5, so the length of the major is 10. And we'll use that fact when we do some problems. The vertices are on the major, so it's a negative 3, and we have a 2, so the vertical is added to the y, so it's 2 plus or minus the b value, which is 5. So it's negative 3, 2 plus 5 is 7, and we got a negative 3, and we got 2 minus 5 is negative 3. That's the vertices. Vertices are lying on the major. The co-vertices are lying on the co-vertices. If the major is the y, co-vertices is the x, so it's a negative 3. Let me move that right there, plus or minus. And we have a 3 here, a, plus or minus a, so it's negative 3 plus or minus 3, comma 2. So again, the co-vertices are horizontal, so the a, which is the value of 3, is added and subtracted from the negative 3, and the 2 is not changed. So that's 3, negative 3 plus 3 is 0, comma 2. Negative 3 minus 3, we did a minus, is negative 6, 2. Okay, let's do the foci. But before we can do the foci, we have to do c squared. Now, it's always the larger one minus the smaller one. So that's the b. So it's b squared minus a squared. So c squared is 25 minus 9. C squared is 16. The square root of 16 is plus or minus 4. So the foci are on the major, so that's a negative 3. And so it's 2 plus or minus 4. Because on the major, the 4 is added to the y value. So we got a negative 3. 2 plus 4 is 6. And we got a negative 3. And we got 2 minus 4 is negative 2. And the eccentricity is the c over the larger one. So that's the c over the b. So the c is 4. The b is 5. So that's 0.8 as a decimal, or 4 over 5 as the eccentricity. Eccentricity gives you, the closer we go to 1, the closer we go to a line, less oval. And the closer we go to 0, the closer we go to a circle. Now we got a graph. The center is x is negative 3, 2. X is negative 3, 2. There's the center. And the vertices lie on the vertical. So it's a negative 3, 7, which is right there. And it's a negative 3, negative 3. Negative 3, negative 3. Now how I do this I plot the center, which is here, and it's vertical, so I go 5 up and 5 down. So I go 1, 2, 3, 4, 5. And I go 5 down, 1, 2, 3, 4, 5. And the co-vertices are on the horizontal, so it's 0, 2. So I'm going sideways right now. So I go right here, I go 3. So 3 units to the right, 1, 2, right there. That gives me that one. I go 3 units to the left, 1, 2, 3, right there. That gives me that one. So I plot the center, and then I do the horizontal stretch and the vertical stretch, and I pick up the vertices are the longer ones, co-vertices are the short on the minor. And the foci are on the vertical, so it's foci is 4, so you go 4, 1, 2, 3, 4 right there, and you go 1, 2, 3, 4 there. So the foci are negative 3, 6, x is negative 3, 6 right there, and negative 3, negative 2, negative 3, negative 2. So let's draw the ellipse. There it is. And again, notice that this is vertex 1, vertex 2. And again, this is co-vertex 1. This is co-vertex 2. And these are the foci. Foci are shorter distance away from the center. This is 4, so this is F1, F2. And when I'm doing an ellipse, I always draw the diagram for myself on the side on the sheet of paper very quickly, so I can see what my vertices are. Again, from the center of negative 3, 2, I'll go vertical. I'll go 5 up and 5 down from the center, and I'll go 3 left and 3 right from the center. And then I'll do the stretch. The foci is on the vertices, so it's up and down from the center. That's the way I do it. Okay, that brings us to the end of the video. Oops, I got my sheets there. I got my sheets, and I can't find my other sheet. It's gone. There it is. Got a backup sheet here, just in case. Again, if you like my video, click the like button, click the subscribe button. If you wish to subscribe to my channel, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content that's on my YouTube channel called Math Fully Explained. Just all one word. Thank you for viewing my video. Hope the video was helpful to you. Bye-bye.